All right. Jumping into this, the idea behind how you graphed yesterday, the reciprocal ones, the secant and the cosecant, is going to lead us into how we graph tangent and cotangent as well. And one of the things I always told you on each of those problems was think about the denominator, right? If I were to write this in terms of sines and cosines, secant of x is the same as 1 over cosine of x. So what I would be thinking and graphing initially is if it had said negative cosine of 3x minus 1 instead of negative secant. On this one, you should have changed the period length. The b value is 3. Period is always 2 pi divided by that, and that does not simplify. So you should have a period of 2 pi over 3, labeled on your 4th tick mark from our technique here. I have a vertical shift of 1, down 1, and an amplitude of 1, so numbering by ones will work. And start just with that, our vertical shift of down 1, so move your midline down 1. I'm graphing cosine and reflected, which means my first dot should have started 1 below my midline at the y-axis. Your first dot should have been here. Go to my next tick mark at the midline, up 1, midline, down 1. Repeat my process over here. All of my dots on my midline become my asymptotes. Those are where cosine is equal to 0, which makes secant undefined. Use all of my dots off of the midline to draw parabolas that go away from my midline. All right, what questions do you have for me? All right, today is the last of our trig functions. We have learned 4 out of the 6 of them, and today we add tangent and cotangent. Now, the process that we used yesterday to learn how to graph secant and cosecant is going to continue through today, and that is focusing on the denominator of the fraction. So as we go to graph tangent, what I'm going to ask you to do is think of the fraction that tangent is, and tangent is sine over cosine, and we learned that way back when we were learning our unit circle. And so when we look at this, very similar to secant and cosecant, when the denominator of this fraction is 0 or hits your midline, tangent will be called undefined or have vertical asymptotes. And so again, what we're going to do is always dot out the denominator. So the nice part about today is that first step does not change, is we focus on the denominator and we dot out that denominator. Our denominator for tangent is cosine. And so I put all these little dots out here for a normal cosine curve. And all of those dots that fall on our midline mean that cosine would have a value of 0. And if I were to put a 0 in the bottom of this fraction, I would get an answer of undefined. And so at all of our dots on the midline, we will draw a vertical asymptote, just like we did yesterday. So I have 4 dots on my midline. At those 4 dots, I'm going to draw in a vertical asymptote. Now, that's where the similarities stop, okay? For this next part. Now, I will never do this again. This is the one and only time that you will see this. But okay, if cosine is 0, it made my tangent answer undefined. But what about those times when sine was 0? What if I put the 0 in the top? Okay, if I put the 0 in the top, 0 over a number is 0, right? So if I were to consider the sine graph, and like I said, I will never do this again, but if I were to dot out a sine curve, you will notice that every place that sine is 0 happens to fall exactly halfway between those asymptotes. You see that? And all of those dots on my midline where sine is 0, tangent becomes 0. And that is the foundation for the 3 dots you must draw for tangent. The first dot you are going to do is on the midline, exactly halfway between your asymptotes. Where you see sine had a value of 0, tangent also has a value of 0. So that's explaining this first dot. This dot right here. So you will now draw your 3 tangent dots. The first dot goes exactly halfway, so on the midline. Halfway between the asymptotes. That's this guy. Now, the next dots, I can explain to you where these are coming from. If I were to look at exactly halfway between 0 and this first line, which is pi over 2, we'd be talking pi over 4. If you go back to the unit circle, tangent of pi over 4 was square root of 2 over square root of 2, or 1. And so what we would do is then, I always say the same pattern is you're going to go over halfway, up 1, because at pi over 4, tangent has a value of 1. So you're going to go to the right halfway. If halfway does not make sense to you, I'm talking halfway between the center and that asymptote to the right of it. So I'm going to go right halfway, up 1. And similarly, we go left halfway, but tangent of negative pi over 4 would put us in quadrant 4, so tangent is negative 1, because tangent is negative in quadrant 4. So we go left halfway to negative pi over 4, down 1. Okay, those are your 3 tangent dots every time. I have one little tangent picture drawn now, and it squiggles through those dots, slides along my asymptote, but keeps going up and down forever. So then I just fill in between all asymptotes in that picture. So I've got a set of asymptotes here. We follow those same 3 dots every time. On my midline, exactly in the middle. Right halfway, up 1. Left halfway, down 1. Tangent is the one that will increase between my asymptotes. And over here, exactly halfway between my asymptotes on the midline, right halfway up 1, left halfway down 1, so that tangent is increasing as I move from left to right between my asymptotes. You are welcome to fill in on the outside as well. You do not have to. This one would just be kind of like the left half of that tangent. This one would be like the right half of the tangent curve, or you can draw a full curve, I don't care, or nothing, as long as you fill in between the asymptotes. Sarah. So ignore the cosine dots? Yes, that is huge, because that's a big change from yesterday, isn't it? Notice all of our cosine dots that are off of our midline, we will ignore these. Okay, so all of the only thing we needed cosine for was where to draw our asymptote. And at that point, then the dots for cosine end for us. They don't do anything as far as my graphing of the tangent. Yesterday, we needed those dots off our midline. Now we do not. Questions? Okay. So moving to cotangent, it is the exact same idea, but don't get ahead of me, because cotangent looks a little different between the asymptotes, okay? But we start with the same process. Is you are going to focus on the denominator and start by dotting out the denominator. So I come over here and I dot out a sine curve. And again, we only care about the dots on our midline. We will ignore the dots off of our midline. So I use those 5 dots that I have on my midline to draw in my asymptote. That process is no different from tangent. The same argument that I had for tangent as to where I put that first dot happens with cotangent. It is 0 when cosine is 0, and cosine is 0 exactly halfway between our asymptotes. So our first cosine dot, so our 3 cosine dots, again, will be on the midline. That's key. It has to be on the midline. I didn't mean to cross that off. Midline. On the midline, exactly halfway between your asymptotes. So my first cosine dot is exactly halfway between my asymptotes. But remember that cosine is just the reciprocal of tangent. So the thing about tangent's value of 1, when you turn 1 upside down, isn't it still 1? But pi over 4 is left halfway up 1. And so what happens is it looks like that tangent graph turned upside down. They are reciprocals of each other. That should make sense, okay? And so what happens is your cosine graph is actually going to decrease between your asymptotes. So the second dot I would do is actually go left halfway up 1. So I go left halfway up 1. There's that pi over 4 comma 1 dot that we had in tangent. 1 is still 1. And then right halfway puts us at 3 pi over 4, down 1. Well, that's quadrant 2. That's why it's negative. Tangent and cotangent are negative in quadrant 2. So we decreased between the asymptotes for a cotangent graph, which again, should make sense because it's the reciprocal of tangent. So it makes sense that the graph is turned upside down also, right? So our third dot is right halfway down 1. This one decreases between the asymptotes where tangent increases between the asymptotes. And besides where their asymptotes are, that is the difference between those two graphs. When you graph these, it is a requirement that I see all 3 of the dots to show where to graph that. On a normal curve, it's not that big of a deal, but when we start putting transformations in here, that is the only way I can tell that you have the correct transformation. Okay, so you have to put all 3 dots when you are graphing those. And again, remember the big difference between the pictures. Cotangent is going to decrease, where tangent is the one that increases between your asymptotes. Okay. Questions so far? Okay. So from here, what we need to look at is transformations. The one common thing that I see on this is people want to continue to use the dots from like our sine curve that were off of our midline. And again, remember that those dots are ignored. We do not use the dots from our sine curve that were off of our midline. Sometimes people will like try to like alternate or like use them. It is different than yesterday. We only use the dots on our midline, right? And if that means you want to go through and erase the ones that are not on your midline because they're bothering you or distracting you, you can do that. But there is a slightly different process than what we saw yesterday. This is also a slightly different process than we saw yesterday because we don't need the dots off the midline. But those 3 dots that we put for our tangent and our cotangent, when you go right halfway up 1 and left halfway up 1, instead of 1, I should have said up the amplitude. That dot is the only way I can tell that you are doing the correct amplitude. And so when we graph this, if our amplitude changes from 1, that second dot moves to whatever that amplitude is. Questions? All right. All other transformations are taken care of by graphing the denominator like we know how to graph the denominator. So first thing we will do is think about what is the denominator. Tangent is sine over cosine, which means I would focus on this being a cosine graph to start with to get where my asymptotes are going to be. Okay, so the first thing I'm looking at is what if instead of tangent, this was cosine, Remember that I can slide that x off to the side and call it 1/2 x. That is not the graph I'm graphing, but it's going to get me started, right? The denominator is going to get me started. Treat it as if it were that graph, which means it'll help me understand where to move or how to label my axis. If b is 1/2, that means the period is 2 pi divided by 1/2, and 2 pi divided by 1/2 is 4 pi. So my numbering becomes 4 pi and 2 pi. I do have an amplitude of 2. You do not necessarily have to do the ROXs and amplitudes when you graph these, but I'll always just kind of keep putting them in there just to continue to practice correctly. Cosine with an amplitude of 2 means I would start my dot up here and then go to my midline. And the midline dot is really what I care about now, right? And then 2 below, and then return to my midline, 2 above, repeat that process back this way. And remember, I don't care about these dots. I care about the dots on my midline. And so I use my dots on the midline. And if I want to go through, you are welcome to do this. At this point, once you have it done, if you want to just erase and erase, you don't need the dots that are off your midline. You need the dots on your midline, and that is it. Draw in your asymptotes from where our cosine graph hit our midline. And then we need our 3 tangent dots. And this time, because of our amplitude of 2, our dots that are off our midline have to go a distance of 2. So my first dot will always start on my midline, but then I'm going to go over halfway up my amplitude. And that's why the 3 dots become important, because that's the only way to show that you have stretched this graph vertically. Left halfway down the amplitude. So there's my 3 tangent graphs, or 3 tangent dots. Squiggle through there, repeat between all asymptotes. Exactly halfway between them on my midline, over halfway up the amplitude, left halfway down the amplitude, squiggle between my dots. Okay. Questions? Yes.
If we don't put the arrows, will we get counted off?
No. Other questions? All right, so we just have a couple more examples because we need to see like the different variations of like vertical shifts, ROXs, things like that. Phase shift. So just kind of one of each of those types of examples. Next one is a y equals negative tangent x plus pi over 4. So 2 transformations for us to talk about in this one. The phase shift will be taken care of when we graph the denominator. So again, we focus on this being a cosine equation. B is 1, so it does not change my markings here. I just have no vertical shift and an amplitude of 1. I've been forgetting to draw my midline when we haven't moved it, but draw in my dots for a cosine curve, move to the left, pi over 4, and this is always the ugly one, right? Halfway between our tick marks, which means all my dots will fall halfway between our tick marks. So normally cosine would start up at 1, but because of the ROX, it's going to start down. Halfway to pi over 2 would be pi over 4, so it's going to start down 1, halfway between those tick marks. So now following my process, all of those dots are going to fall halfway between my tick marks. So my next one would go here at positive pi over 4 on my midline. Halfway between my tick marks, up 1, halfway between my tick marks on the midline. If you don't get the ROX in there, it's not a big deal for the cosine dots, because where it hits your x-axis or where it hits your midline will not change based on if it was reflected or not. And again, that's all we need from this. I need to know where it hit my midline. So I use those midline dots, which again all fall between my tick marks because of our ugly phase shift of pi over 4. And now seeing an ROX of a tangent curve. Well, what happens is with an ROX of a tangent and a cotangent is they basically end up looking like the other one because it just flips each of those dots upside down. So in a tangent curve, when you have an ROX, it will now decrease between our asymptotes instead of increasing. You'll follow the pattern for a cotangent graph. So I find exactly halfway between my asymptotes and I still put my dot on the midline. But instead of going right halfway up one, I will go left halfway up one and make my graph decrease between the asymptotes. And an ROX of a tangent curve looks just like a cotangent curve, okay? Just like when we're doing transformations of sines and cosines and secants and cosecants, they all look alike. I get that because they're all related. So there is your example with an ROX. Any questions? Okay. Three cotangent of 2x. So our example with a cotangent, again, we start by identifying for ourselves what the denominator is. Our denominator of cotangent is sine. So we will think through this as a sine graph, dot out a sine graph to find our asymptotes. So again, start with labeling. B equals 2, therefore the period is pi. And I have an amplitude of 3. To do that, I'm going to go ahead and just kind of put in some tick marks in there. Dot out my sine curve. There it is, the two transformations that were supposed to take place. My midline does not move from the x-axis. Sine curve, and again, we really care about those dots that are on our on our axis, on our midline. Because those are what will give us our asymptotes. Okay, this is a normal cotangent graph. Normal cotangent graphs decrease. So now I find exactly halfway between my asymptotes on the midline and make it decrease. So I go left halfway up the amplitude of 3, right halfway down the amplitude of 3, and fill in that same pattern all the way across. Okay, questions? And again, because of our labeling here, it has taken care of our amplitude of 3 in that picture by showing our dot that is 3 above and below our midlines. We have one more to go through, and that's one with a vertical shift on it. We have not seen a vertical shift. So negative cotangent of x plus 1. Also looking at an ROX of a cotangent curve. It is important that you remember which is in the denominator for each so that you know which one to be dotting out in your picture. If it is cotangent, your denominator is sine. So I'd be graphing this as a sine curve to start with. Okay, and our major transformation on this one is the fact that it is up 1. And so the first thing I'm going to do is go draw my midline up 1. And just like we have continued to graph all of them, it is now all relative to that midline, right? Including my sine curve. So my sine curve starts on my midline. The ROX makes it go down 1, back to my midline, up 1, back to my midline. And again, we really only care about the dots that are on our midline. So if you want to, at this point, you could go delete the dots that are off your midline if you find that they are distracting you or making you do things incorrectly. But I really only care about those dots that fall on my midline, and that is where my asymptotes will be drawn. This is also your one example of an ROX with a cotangent. An ROX with a cotangent specifically means it will now look like a tangent graph or increase between your asymptotes. So now we follow our pattern. Our first dot must start on the midline. So I'm going to go exactly halfway between my two asymptotes on the midline. Because of the ROX, we're going to make it increase. So go right halfway up 1, left halfway down 1, make it look like a tangent graph, because it's an ROX of a cotangent, all relative to our midline. Midline is up 1, so my first dot starts on the midline, increasing for the ROX of the cotangent curve, all the way across. Same pattern. Questions you have for me on tangent and cotangent? You guys again have a worksheet, but at this time we are going to do our sine and cosine unit objective quiz. So if you will please get this worksheet and put it away. Have out just a pencil. And Jordan, I'm going to assign yours to you on Google Classroom right now.